Hello, good morning from London. Good afternoon, good evening. Hello. Today's about curves. It's all about the curves, the curves, the curves. It's all about the curves, the curves, the curves. It's all about the curves, the curves, the curves. It's all about the curves. And let's draw some curves. So we're going to start with, that word quadratic comes in here later, and parabola. Now I love that word parabola. It has a great sound to woo. That's not a parabola, FYI. Woo. Oh, look at that. You can make art with a parabola. If you make that parabola slightly shorter and end at that point, woo, you can make parabolayan art. There you go. You can find a way to integrate curves and parabolas into your activities. So this activity is aimed at 7 to 18-year-olds. There is a separate activity for early years, which is all about the curves, not specifically about parabolas. It's just all about the curve, the curve, the curve. And that will be live in an hour. And if you're on the replay, it's easy to find. So I'm just going to share as a watch party so that we have that as well. Now, there's a few things here. I'm going to go into doing more what they have in the resource, what's available in the resource provided by AIMSEC on the Aiming High website. The link to the activity is in the description, but we're going to talk about curves. It's all about the curve. I like my fishy, actually. I'm going to give him an eye. Happy fishy. And some bubbles. Blub, 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 blub. There you go. All about the curve. Circles are curved too. That's interesting. They're not parabolas. There's a different equation to describe a circle than a parabola. The parabola is kind of like a parallel lines. They only meet in one place, and then the rest of the time they go, woo, they just keep going apart. Now, parabola. Here's a parabola. Whoop. Can you make a parabola? Now make sure it's something soft. You can do it with a soft toy. You can do it with, whoop. You can do it with something soft, something you know you can throw and catch safely. Whoop. Oh, let's start this watch party. I'll say on there, it's all about the curve, the curve, the curve. It's all about the curves. Now, the idea is that even if you're not, oh, hold on 1 second. Oh, no, it's down there. I can't get to it. I've lost one. I can't do my proper juggling now, thank goodness, because it was going to be a bit of a disaster anyway, so that's fine. If you just got to find the screen you're on. Okay, that'll do. The parabola. So I've made a parabola with this one. I'll make a parabola with this one. Oh, I like the orange one. Let's do a parabola with the orange one. That's a parabola. It's what happens automatically. So the forward motion of the ball, the way and it goes that way, is caused by the force that I give it. I using my arm to push it in that direction. I'm also pushing it up. But then you've got gravity that's pushing it down. So this isn't just math. This is maths and science or physics. So, and this is the curve that the combination of the force being pushed that way and the gravity. So I'm pushing the ball that way. So if there were no gravity, it might keep going on forever and ever and ever and ever. If nothing changed its direction, it would just keep going in whatever direction I sent it in the first place. But because there's gravity and there's other forces, there might be wind as well, but let's pretend there's no wind and no atmosphere. There's no influence of gravity, it would just keep going straight. But because there's gravity, whoop, it comes whoop back down again. As always, the curve is always the same. I mean, it's a different curve because I apply a different angle when I throw it and a different amount of force, but the shape of the curve is always a parabola because we're on Earth, and that's what Earth does to things you throw up. Now, What else does that? Can you think of another thing that you could go up in the air and it makes that shape? When it's free to move, it makes that shape. Have you ever got your hose pipe out and aimed water with a hose pipe? It goes that way, doesn't it? And what else? There's I've got some pictures here. Shall I perhaps turn on the visualizer and show you some other shapes that I've got here that are, oh my goodness, the visualizer is not active yet. Gotta go and find it. Hello, visualizer. Gooey, visualizer. There you are. I keep looking for a green thing and it's not green, it's blue, just to confuse me. Now, can I turn on the visualizer? That's a share screen. Where's the visualizer? Okay, let's do it again. Oh, it didn't work, that's why. When I turned it on, it didn't work. Right, bear with me. Problem report. There's a problem report for the visualizer. That doesn't sound good, does it? Problem, oh, okay. Reopen. Problem report. Now is it solved? Well, I'm just going to have to show you a different way. I'll show you this way. And what we have here is, we're going to do that for, okay, here we go. Well, I suppose this works as well if you're, so this is what we're going to show the early years. We're going to do a whole thing based on this on early years. So this is just curves. Now, unless you're actually flying off the end of the water park and actually going upwards, you're not going to do a parabola. But if we're going to introduce the idea to early years, or if you're on a skateboard and you fly over a ridge and you go whee down, that's a parabola. Skiing as well, if you go down the ramp and you do a ski jump, whee, you do a parabola. You follow the path of a parabola. There's also, by the way, a quadratic song. In fact, there's a number of quadratic songs. I've put a link to it on the live, onto one of them. And if you Google it on YouTube, there's a few quadratic songs that you can have a go at and get into and enjoy quadratic songs. There's lots of different ways of doing it so that it's fun and enjoyable, and it's all about the curve. It's all about the curve, the curve, the curve. It's all about the curve. Here we go. Here's some examples of some parabolas. A cannon gets shot up and it goes into a fort or onto a boat, or splashes next to the boat, hopefully, and golf and cricket and football. When you're on a football field, you're watching football, the football goes wee, up and down. It follows a parabolic. So footballers are doing maths. And basketball, if you throw the basketball upwards and into the hoop, on its way to the hoop, it follows a parabolic path. So sports people that use a ball, and even high jumpers, if you jump, or trampolinists, if they trampoline off the trampoline, if they go one way and another way, they're following a parabola. In the circus, when the trapeze artists fly wee off the trapeze and onto another trapeze, they're following a parabolic path. It's all parabolas. It's all about the curve, the curve, the curve. It's all about the curve. Whoops, that's a parabola, very tight one, but it's still a parabola. And this is going to be, I'm going to switch off the visualizer and switch it back on again, because we do actually need it for the next bit, or else I'm going to have to do it in front of the camera, which won't be very good. Won't be ideal, that's for sure. I think I might have done it again. I might be attempting to make the visualizer work when it wasn't the visualizer that was plugged in at all. It was something altogether different. So no wonder it didn't work. Here we go. And visualizer on. Now it's going to work. So that'll be fine. We'll do that in a minute. And let's see what else we've got here. And then we go to where we're going on the visualizer. So what we've got, and I'm going to do this on the visualizer. So that's for early years, for primary. The idea is I want you to have a go. I want you to actually, you can use you can film it as well. You can actually track the path. You can do it in slow motion, film it in slow motion. And everyone throws something different. Go outside and throw something different and track it, film it and track it slow motion. And then you can draw it afterwards and see what it looks like. And so the idea is that is you're just getting familiar with the word parabola, and just I'm going to say we're going to learn about quadratic functions now, so you can stay and watch. That's the equation that, so I've got an equation here and it looks complicated, but let's say, oh, I don't want to get rid of it. Oh no, you can't see what I'm doing. Oh, you can. No, I'm not even going to bother. We'll just do it on there because I want that for my early years. I like that one. It doesn't matter. It's a parabola. It's a quadratic equation, and it's a parabola, and it's what you do with your ball. That's all you need to know. Just get comfortable with that, and then when you're ready for it, when your teacher says quadratic equation, you're going to go, yes, I know what that is. It's a parabola, or at least this one is. And yeah, so that's basically what it is. Now, I am an engineer, and I have to say that especially in sport and in engineering, there's things you have to know about parabolas. You have to be able to do the equations, and this is real life. This is a parabola describes something that happens in real life. So there's pure maths, and that is maths which is theoretical. You can make copies of it, like you can say, well, this is a rectangle. Well, it's not really a rectangle because it's a piece of paper and it has thickness, so it's actually 3D. It's not a 2D shape at all, and plus it's not completely flat. Look, it's all wobbly, so it's not. It is a representation in 3D of a rectangle, and there are also things you can do in 3D that, but we can't make it perfect. Even if we're talking about a 3D shape, it's not perfect, especially if I make it. So in pure maths, they deal with perfection. They deal with like the ideal, which is very exciting, and some really interesting things. In applied maths and applied physics, it's all about what happens in real life. So quadratic equations actually describe what happens in the world around us. And there aren't very, it's one of those really obvious ones that you can actually throw a ball and then write a formula for it. Hey, who knew? You could write a mathematical formula for this. Huh, this is great. I'm going to do that again. Oh, I wonder what that one is. Oh, there's slightly different formulae. But if I drew an axis here and I throw it up and down, I could then map that path and create a formula for it. So we're going to do that now. And I'm going to, hopefully now that I've plugged it in, my visualizer is actually going to work. It does help if it's plugged in. That's my experience in life. So I'm going to stop this share. I'm going to make a new share. Drum roll, everybody. Give me a drum roll, please. If this doesn't work, I'm going to have to find a way of doing it. So the visualizer's there. It's plugged in. That is the correct one. And whiteboard, iPhone, visualizer. Yes, 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 yes. Right, here we are. So what we've got, it's all about matching these formulae. So now I'm talking to secondary school kids, okay? 11 plus, well, more like 13, 14 plus. So up until that point, all you have to do is know it's a parabola. A parabola, it's all about the curve, the curve, the curve. Now down here, I have an exercise to do. So I want, if you can manage to download it, great. What I'm going to do is, what we need to do is match these formulae to these curves. Now I'm actually going to cut out some of these formulae. Now I've got a few more here. So the first exercise actually in this activity is to make groups, to group them. There are 7 quadratic functions here, only 7, and you've got 2, 4, 6, you've got 14 equations. So you've got to group them into the 7 sets. So I'm going to cut these out as it's going to make the next job easier. So the first thing we can do is actually identify the functions. Now I'm going to cut down here. I find personally that if I can actually move something around, I personally find that makes it easier for me to use it. So I like to be able to take these equations and move them around and actually physically group them instead of writing them down or talking about them theoretically. So I'm now going to take these. I'm not going to do the grouping function. I'm going to allow you to do that. It's in the activity. You don't have to print it out. You can just write them out on a piece of paper if you want to. And let's see, get those all together. And snippety snip, glop. Right, now we want to find y equals x squared plus, oh look, we've got the different types. Here we go. There's that one. That one's like that one. I'm not going to put them all together. I'm just looking for that one. Is that the same as that? Is that the same as that? Is that the one? Is that the one? Have I found the right one? So what we're going to do is take each one of these. First group the types of equations together, and then we're going to identify which of them match which curve. So for this one, we'll just do the first one. A great way of identifying at least whereabouts it is make x 0. Where is y when x is 0? And we don't have the scale of these, so where is y? What is y? If x is 0, what is y on that one? I'll bring it a bit closer to the camera so that we're absolutely clear which one we're looking at. If x is 0, what is y? X 0 squared is 0, 6 times 0 is 0, so y is minus 16. So first thing you can do is you can eliminate a whole bunch of these when clearly when x is 0, so on this line here, where is y? So y first of all has to be below 0. So it can only be this one, and this one. Those are the possibilities. And then you've got to now you literally plot the graph. So you know it's one of those, so you've established that much, and then you just plot a few of the points to figure out which of the curves it is. So that's the exercise. Do that with those 7 formulae and identify which of these match which of these curves. So that's the thing to do there. And I'm now going to stop sharing this one and go back to sharing the other one. I'll do it on this screen and share. I don't know how I managed to get it last time. It was really cool what I did last time, but it's not coming up this time. So, so do that exercise And then, oh, in upper secondary, so do the card matching, sort the 7 of these into different types, and into the different 7 types, and then there's more things you can do here. So some questions for you to follow on there, and it'll give you some practice in doing them with some additional questions that will hopefully give you greater understanding. So you get both practice and understanding by doing this. So it's a good, this activity was written initially for the upper secondary. So it is meant to help you review your quadratic equations. So this is actually a really good time to do it. I mean, when this is being filmed is at a time when if you're looking at this years to come from now, this is during the COVID-19 pandemic, and a lot of learners around the world haven't actually taken their exams this year. So it actually might be a really good thing to review, so that you've done it, or even like if you're at your first year of uni, just to review, just to make sure you've got your foundations solid, was really helpful. And then the idea is that the whole point of doing this exercise is to identify, I'm not showing you the solutions, here we go, identify different types of quadratic functions. I'm just reading this, connect the functions and the properties with the intersections and the axes. And what you're going to get in addition to simply doing the exercise is you're thinking mathematically, you're reasoning logically, you're being asked questions that you actually have to answer. Not just, is this right or wrong? Have I done this right? If I've done the maths, there's nothing else there? There is, especially if you're using the activities that you get on the Aiming High website, is that you're having to give explanations, you're reasoning logically, you're thinking flexibly, you have to be creative, innovative, and apply your knowledge and your skills, because you've obviously got accumulated knowledge and skills, because you can do quadratic equations. And this is the first time, if you haven't done them yet, but you feel you're ready to do them, then have a go, because it's all about substituting. So if you know to do your X and Y, just plot your graph, your Y and your X, I should say, just put in different numbers, change the number for X and put it on the graph and see what happens. Have a go. That's one that I certainly used to enjoy, plotting graphs. I'm like, yes, plotting graphs. Yes, I love this. And it's visualizing. So you're visualizing a parabola, and go out and do that. Film the parabola, go and get your ball and film it. Find different things that you can film slow-mo. And if you can put a grid behind it, so if you get a nice big sheet of paper and put a grid on a board like this or something, and then film it slow-mo, and then you can plot it on the graph. I think that's a lovely idea. So if you're enjoying these videos, this one was a bit intense. If you're enjoying these videos, and yeah, it's real life. It is real life, so it's practical and useful. If you're enjoying the videos, please do share them. Please tell people about the Making Maths Fun for Kids of All Ages group and encourage them to join. I can do that on Facebook or in person. And we also have 2 YouTube channels, which I've been tasked to populate one of them, which has been a bit slow, I'm afraid. I apologize, but it will, we will get more and more and more videos on there, which match the activities on the Aiming High website. And the great thing about the Aiming High website is that all the activities on there are low threshold, high ceiling. So they're going to take you, and especially since we've been adding, well, not me, Tony has been adding, Tony and other people have been adding activities, that home learning guides and inclusion. So that's for special educational needs as well. It starts at nursery level. And so they really are low entry, high ceiling, low threshold, high ceiling. So you can start at whatever point you want. You can start by doing art. You can start by just playing, really just playing with toys, and then go through the activity, and you get to a point where you're like, okay, well, I know this, I'm comfortable doing this. And that's when you think, okay, now I'm going to stretch myself. And the thing is, you can keep coming back to the same activity because you're building on prior knowledge. And next time you come, you'll find you can get to a higher level. And then again, stretch yourself and stretch yourself just that little bit so that you don't actually know the answers. You're like, I don't know how to do this. And that doesn't mean that you aren't capable of doing it. It just means that you don't know how to do it yet. Did you know that mathematicians only find a problem interesting if they don't know how to do it? Does that mean they can't do it? Well, actually, there are some problems out there. There is a £1 million prize out there. There are a few problems that haven't been solved yet, and there is a £1 million prize, and it's still unsolved. And there are people who dedicate their lives to solving these problems, and they're still unsolved. So that's what a mathematician finds the most fun of all, is to actually see if they can possibly find a way to solve a problem that hasn't been solved, or purely if they find something, oh, I don't know how to do that. Oh, let me find out how to do that. That's what a mathematician finds interesting. Do you think mathematicians are clever? You bet they're clever. But you know what? So are you. Oh, and what makes them clever is that when they find a problem they don't know how to solve, they get excited and they think, oh, I want to find out how to solve that. And that's what makes you clever. Find a problem you don't know how to solve, you think, oh, I want to find out how to solve that. But also recognizing if you're not ready to solve that one, then come down a little bit and build up to it so that you can solve it. So thank you for joining us. I guess go and have a look on Facebook and let's see who has joined us. Oh, I've been talking, I apologize, I've been talking in the little bitty square again, haven't I? And you've been looking at learning objectives. I definitely need a producer for this show. Right, now I've got to look at, here we go, I've got to look at Facebook and see who came to join us. We had Noeli again from Tanzania. Russell, hello. Stuart Barber from his son's a little bit young for these sessions yet, but actually for the early years, Stuart, Seth could come on the early years. Mind you, his mum's maths teacher. So although his mum might get some inspiration from our sessions. Giuseppe joined from Barcelona. Andy from Lowestoft. Barbara. I don't know where you are, Barbara. You never know where Barbara is. John Cooper, that's Frosty. Sime from Singapore. Just Singapore, right? Not Malaysia. Aileen, I don't know where you are. And Jill, thank you so much for joining us. Thank you for coming, and I will end this live as soon as I find out how. I'm an electronic engineer. You'd think this would come naturally to me. So there you go. It doesn't mean that I'm not clever. It just means that I am learning very slowly, but I'm learning. I'm 58 years old and I'm still learning, and I'm happy to be doing it. Right. Thank you very much. Have a wonderful day.